Hi friends, welcome to my channel. Let's have a look at a classic problem, problem 14, longest common prefix. In this video, we're going to practice the trie data structure, also known as prefix tree. In this problem, we are required to write a function to find the longest common prefix string among an array of strings. And if there is no common prefix, we just need to return an empty string. So here are two examples. So in the first example, you can check if we do the search, you do the scan. So FL is the common prefix for the strings in the list. Therefore, the output is FL. And in the second example, the first word starts with D, the second word starts with R. Therefore, for all the strings in the string, so they have no common prefix string, so we return empty string. The additional assumptions or constraints are the following. First, the list has a length bounded above by 200, and each of the elements in the string in the list has a length bounded above by 200 again, but the element can be empty string. So here a string consists of only lowercase English letters. So with that said, so we can explain a solution based on the prefix tree. So typically, because of the size of the problem, here is 200 and 200, maybe we can use a scan and compare the common ones. So that's a solution. However, that's not very efficient. So here we would like to explain a solution based on the prefix tree data structure. If you do not know the abstract data structure, you can review in my playlist in the YouTube channel. So here in this video, so we are going to regard the trie as a nested dictionaries, or you can see each level a dictionary corresponds to a node, so it's still a tree structure. Overall, I would regard this as a recursive abstract data type. And then once we realize this point, actually providing a solution to this problem is very routine. So here, after we absorb the idea of trie, I'm going to traverse from the beginning and return once we meet a dictionary with more than one children, or just with you can regard this dictionary as node. And or we also need to stop if we find the end of words key. So here I'm using pound as the end of words signal. So with that done, so we can do the coding. So there are two choices actually. So either we use the trie implicitly inside this function, or we implement a trie abstract data type and then call that instantiate an trie object. So because this problem is very easy, so I'm going to use it within the function. So I'm going to initialize a trie. Initially it's empty. So now what I'm going to do is to insert the word. Insert words in strings to the trie. So this is the very standard. So basically I'm going to use a for loop for word in strings. So what I'm going to do is basically we want to use a recursive format. So here of the data structure, so not the recursion in the coding. So here, this is the current node. I'm going to regard this as the outset dictionary. And then what we are going to do for each word, then we are going to iterate for character in a word, right? If character not already in the node, in the current node, then what we are going to do, we set the current node with an empty dictionary, and then we are going to update this node. So within this for loop, this is another for loop. So what we're going to do is node equals node character, right? And then after this for loop, we finished inserting words to the data structure. Therefore, we're going to mark this at the end of word. So you can type anything. What we care is that this key is in the dictionary. So let's use true, maybe just Boolean, right? Or just whatever you want. So this is the first step. So next, actually, we can use the problem logic here. You know, in the typical trie abstract data type, so we have a search for a word or check if given string is a prefix for the words. So here we can directly check the longest prefix. So we just need to iterate over this trie. For this purpose, I'm first going to initialize an empty string, and then we're going to iterate while this trie, right? If it's not empty, then we're going to look at the current number of children, or in this setting, the number of kids. So I'm going to use this list trie. So notice that trie is a dictionary, so we can call kids method, right? So because this is a key object, so we use a list in order to find the first one. So then we're going to check the length of this key. So if kids is greater than 1, it means that the current dictionary or the node have multiple children. So this is the one case we need to return. Or if this guy, this pound, according to our convention, is in the dictionary, in the case. So let's use this to check anyway. Then what we are going to do? So we are actually need to return in this case, right? So otherwise, what we are going to do, we are going to add the current character because we just have one case. So we are going to use this case 0. So now this case is a list, so we can call this. And we know this is just a single element, right? Then we are going to update the trie to be the trie. So this is the dictionary, right? And then add the current character. So actually this character, let me first get this. Character would be case 0. And then what I'm doing here is adding this character. And then we are going to update the trie state to be the trie character. So this forms a solution format. So I guess this is easy in coding and logically succinct. So before we do anything, let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case. So here, actually, the small thing, because here we use the case to check. So actually, we can directly check in trie. This may be better because this is a dictionary. This membership check is O of 1, right? So now let's run this again, right? Yeah. Anyway, so this is one way of doing this solution. So before we end this video, let's make some extension. So maybe we'll see, can you try to implement a trie as a class, and then instantiate in the main function, in the function here. So here is a function, I mean this one, and then incorporate the problem logic. Yeah. So that's an extension. So here, because this problem is very straightforward, we don't need to go that level of abstraction. So we can just initialize and then insert words and then do prefix check, right? So, but you know, if you want to get a better understanding, maybe this extension is a good exercise. So with that said, if you find the explanation useful, you are welcome to follow up or share with your friends. So you can follow up us in the YouTube channel. So with that said, I guess that's about it for this video. Thank you.